What is mercury? Mercury is a naturally occurring chemical element found in rock in the Earth's crust, including in deposits of coal. On the periodic table, it has the symbol Hg and its atomic number is 80. It exists in several forms. Firstly, in elemental or metallic mercury. Secondly, is inorganic mercury compounds. And thirdly, is metal mercury and other organic compounds. So, what about the elemental metallic mercury? Elemental or metallic mercury is a shiny silver-white metal, historically referred to as quicksilver, and is liquid at room temperature. It is used in older thermometers, fluorescent light bulbs, and some electrical switches. When dropped, elemental mercury breaks into smaller droplets which can go through small cracks or become strongly attached to certain materials. At room temperature, exposed elemental mercury can evaporate to become an invisible, odorless toxic vapor. If heated, it is a colorless, odorless gas. Elemental mercury is an element that has not reacted with another substance. When mercury reacts with another substance, it forms a compound such as inorganic mercury salts or methyl mercury. As for inorganic mercury, mercury occurs abundantly in the environment, primarily as the mineral cinnabar and metacinnabar, and as impurities in other minerals. Mercury can readily combine with chlorine, sulfur, and other elements and subsequently weather to form inorganic salts. Inorganic mercury salts can be transported in water and occur in soil. Dust containing these salts can enter the air from mining deposits of ores that contains mercury. Emissions of both elemental or inorganic mercury can occur from coal-fired power plants, burning of municipal and medical waste, and from factories that use mercury. Inorganic mercury can also enter water or soil from the weathering of rocks that contain inorganic mercury salts, and from factories or water treatment facilities that release water contaminated with mercury. Although the use of mercury salts in consumer products such as medicinal products have been discontinued, inorganic mercury compounds are still being widely used in skin lightening soaps and creams. Mercury chloride is used in photography and as a topical antiseptic and disinfectant, wood preservative, and fungicide. In the past, mercurous chloride was widely used in medicinal products including laxative, worming medications, and teething powders. It has since been replaced by safer and more effective agents. Mercury sulfide is used to color paints and is one of the red coloring agents used in tattoo dye. The last type of mercury is metal mercury, when inorganic mercury salts can become attached to airborne particles. Rain and snow deposit these particles on land. Even after mercury gets deposited on land, it often returns to the atmosphere as a gas or associated with particles, and then redeposits elsewhere. As it cycles between the atmosphere, land, and water, mercury undergoes a series of complex chemical and physical transformations, many of which are not completely understood. Microscopic organisms can combine mercury with carbon, thus converting it from an inorganic to organic form. Metal mercury is the most common organic mercury compound found in the environment and is highly toxic.
Do you know that mercury was previously known as hydrogen? This name comes from Greek words hydro and argyris, which means water and silver. From the name hydrogen, this is where the elemental symbol Hg comes from. It has mirror-like appearances and exists in liquid form at standard temperature and pressure. Mercury occurs naturally, but it is a very rare element in Earth's crust. It accounts for only about 0.08 parts per million ppm and is mainly found in the mineral cinnabar, which is mercuric sulfide. Mercury also does not react with most acids. It is a relatively poor conductor of heat compared to most metals that are excellent as thermal conductors. So, the freezing point of mercury is negative 38.8 degrees Celsius and its boiling point is high at 356 degrees Celsius. Mercury existed in three forms: elemental, inorganic, and organic. The elemental mercury is the one that we usually found in thermometers. At room temperature, exposed elemental mercury can evaporate to become an invisible odorless toxic vapor. Elemental mercury is an element that has not reacted with another substance. However, when mercury reacts with another substance, it forms a compound such as inorganic mercury salts or methyl mercury. In its inorganic form, mercury occurs abundantly in environment, primarily as the mineral cinnabar and as impurities in other minerals. Inorganic mercury is soluble in water, therefore, it can be transported in water and occur in soil. Microscopic organisms can combine mercury with carbon, thus converting it from an inorganic form to organic form. In organic form, it is known as methyl mercury. When inorganic mercury salts can become attached to airborne particles, rain and snow deposit these particles on land. But even after mercury gets deposited on land, it often returns to the atmosphere as a gas or associated with particles and then redeposits elsewhere. Methyl mercury is the most common organic mercury compound found in the environment, and it is highly toxic.
There are three types in a way that mercury can be produced in our environment. There are natural source, anthropogenic source, and re-emitted source. The example of mercury that's coming from the natural source including volcanoes eruption, forest fire, and the emission from the fossil fuels such as coal and petroleum. This has contributed to about 10% of the global input of mercury in the atmosphere. Next, the anthropogenic source. The anthropogenic mercury is a result from human activity which can be classified into four categories. The first category is the area source. The landfills, the dental preparation, and laboratory use are defined as area source. The second category is the combustion process. These include the coal-fired power generation, medical waste incinerators, and municipal waste combustors. The third category is the manufacture of alkali, metal, and cement in our industry. And for all other industrial process is fall under the fourth category. The large source of mercury is from the re-emitted source. It is a phenomenon when the concentration of an elemental mercury is higher in terms of the concentration after exiting an absorber compared to the concentration before entering the absorber. It may be deposited and re-emitted many times as it cycles throughout the environment. This means that mercury that was previously deposited from the air into the source and water from past emission can be emitted back into the air by forest fire or biomass burning. The mercury is widely dispersed through the air as elemental mercury, which eventually will settle down in water or salt that finally will be washed away by the rain into the water system. This is the reason why the exposure of mercury is highly related with the pollution in our aquatic system. This event has manipulated the environment in our aquatic system where the inorganic mercury that coming from the air is methylated by microorganisms to produce more organic form of mercury, such as methyl mercury. The organic mercury will be ingested by the aquatic animals and be exposed to humans who actually consume the contaminated fish or other seafood. The bioaccumulation of mercury in tissue layer in humans can lead to many adverse health effects. Besides, the deposition rate of mercury is also found to be high in certain areas due to urbanization and development in industrial areas where acidic compounds are released without proper control.
In terms of toxicological point, mercury consists of three forms based on the substantial differences in toxicity. First is inorganic mercury salts, organic mercury compounds, and elemental mercury. All these three possess different biological behavior, pharmacokinetics, and clinical significance. Mercury poisoning can result through mercury vapor inhalation, mercury ingestion, and mercury absorption through the skin. However, the mercury toxicity is usually acquired through inhalation. Inhaled mercury vapor could lead to severe complications or fatality as the vapor accumulates in the body. In both humans and animals, mercury toxicity are associated with brain problems, as it mainly resides in the central nervous system, which is the site of its significant toxic actions. Human toxicity varies with the form of mercury, dosage, and rate of exposure. The most deadly form of mercury is methylmercury, which belongs in the organic metal group. Methylmercury is easily absorbed through the gut and deposits in many tissues, widely distributed throughout the body. On entry to the body, mercury vapor has great affinity for sulfhydryl groups and bonds to sulfur-containing amino acids throughout the body. Mercury vapor is then transmitted to the brain, either dissolved in serum or adherent to red cell membranes. This mercury passes easily through the blood-brain barrier and rapidly oxidizes to mercuric mercury on entry to the bloodstream. This affects the immune system, alters genetic and enzyme systems, as well lead to renal organ system failure. Furthermore, methylmercury is also a bioaccumulative environmental toxicant that bioaccumulates in marine food web as it can be found naturally in water. Hence, it can be found mostly in aquatic living and is therefore largely linked to eating seafood, mainly fish.
Okay, now let's talk about how can we solve the problem of the mercury pollution. In order to solve this problem, we must look at different stakeholders, for example like community, industry, and government. Number 1. Waste management. It is important to recycle the product instead of producing the new one. This method is being proposed by the Japanese government to convert the mercury from the immobile form to the mobile form of mercury. This can be done by the mercury undergoes the desulfidation, which is the most stable form of the mercury. Number 2. Water management. Mercury can be adjusted in water. State agency delegated is responsible for administering the Federal Drinking Water Safety Act. Number 3. Controlling mercury production. The mercury production is depend on what country can offer in industry. For example, in China, they estimated produce 3,500 metric ton of mercury. That's make China is the highest rate of producing of mercury. However, in Japan, the government limits the production of mercury by recycling waste material. Number 4. The most indeed contributed to prevent any kind of heavy metal contamination, which is the government policy. The government policy is the best one because it is required like actions of the state or action by the courts that relate with any production of any heavy metal contaminations. Like in China, is example of encouraged mercury alternative by Heavy Metal Pollution Prevention and Control Plan 2015. In USA, Environmental Protection Agency EPA is based on Minnesota Auto Mercury Switch Recovery Program. Using this program, USA managed to overcome mercury in various ways such as in the boilers, incinerators, steel makings, and other facilities. The sad thing is, based on my reading, there is no commitment between the country to overcome the pollutions, which are not negotiated. The only thing exists in international levels by regulation trade of unwanted chemical like mercury itself. So, I believe in order to solve this problem, which can lead to the global, we must have any international initiative.
Next, the application of mercury. Mercury are broadly used in various fields of science and technology as well as medicine. The ancient Greeks and Romans used mercury in cosmetics, and it was also one of the primary cures for syphilis in Europe before modern time. Besides, mercury is used in thermometer, blood pressure devices, and thermostat because its ability to expand and contract uniformly make it useful to measure changes in pressure and temperature. Although many liquids could be used in pressure measuring device, but mercury is used because it has high density, therefore require less space. It also good conductor of electric, which make it important element for switches. In addition, mercury is also used in dental fillings, soaps, paint, and fluorescent light. Mercury will dissolve numerous metals to form amalgams, and it is used to extract gold dust from rocks. Amalgam is used in dental fillings because it works as a biocide. Mercury also used in paint because it acts as fungicide, but this kind of paint is no longer sold. Although its toxic effects are well understood, mercury continues to be used in a wide variety of products and manufacturing process because it is very useful.
As a conclusion, everything in this world has both positive and negative effects. Same goes to mercury, where it has both as well. If we keep using mercury in products and processes, it will continue to be emitted and added to the global, where it can recirculate again and again in the global environment. Even if all uses and emissions of mercury were stopped immediately, it is not known how long the contamination of the food chain will continue. It is therefore essential to take action on two levels. First one is to phase out the use of mercury globally by substituting it with several alternatives, and second, to ensure that people are better informed about how to prevent the buildup of mercury in their bodies in order to protect the health of future generations.